I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. So in this video, I'm going to be talking about stereoisomers, and I'm going to give you my tips and tricks to hopefully maximize your studying, because I know this is one of the topics that gets a lot of people, and I promise it's not that bad. In this video, I'm specifically going to talk about enantiomers, and in another video, I'll talk about stereoisomers. So let's get into it. The first thing you have to understand when you're talking about enantiomers and all of that is chirality. So my cheat per se is if you have 4 different groups, then yes, you are chiral. If you do not have 4 different groups, then you are not chiral. If you are chiral, again, if you have 4 different groups on it, you will have a stereogenic center. So that's what I have here. Hydrogen, a methyl, CH2, CH2, CH3, and a CH2, CH3. So you have 4 different groups. Therefore, this point right here is a stereogenic center. It is a chiral carbon, okay? So this molecule is chiral. So you have a chiral center. Okay, so stereogenic center and chiral center are the same thing. Okay. Next thing that you need to know. If you have a plane of symmetry, it is not chiral. So I drew it just kind of like to show you guys. If you draw a line down the middle, see how this group is the same as this group, and this group is the same as this group. So you don't have 4 different groups on it. Okay, so it is not chiral. And then now that you know what chiral is and what not chiral is, so then you'll be able to see enantiomers. So I drew here a chlorine, a bromine, a CH3, and a hydrogen. So it passed the test. It has 4 different groups. Now, there's 2 ways of drawing enantiomers. So you have the swap method. So if I drew the bromine with, for example, a bold and the chlorine with a dash, that would be one example of how to make an enantiomer. But another way of making an enantiomer is imagining that you have a mirror and flipping it over the mirror. And so that's what I did here. So then what you'll be able to see is that when you do RNS, for those of you that don't know, I'll do an RNS video on that, but you're going to have to trust me for right now. Even though you're like, oh, that's the same thing. No, it's not. And you'll be able to see that like one's going to have the R configuration, one's going to have the S configuration. So another way of saying it in English is that you have a different arrangement in space. Okay? And so that should make sense. Okay, so I don't like just giving topics. I love giving examples, so that way you guys are able to consolidate the material. So if you go check out on YouTube, I'm going to post this full video, and let's keep going. So here is my examples. So you have locate the stereogenic centers. So here are my tips and tricks. So if you have any double bonds, automatically cross out that carbon, because that's not going to be a stereogenic carbon. What were the rules? The rules were that it had to be sp3. It's not going to be sp2 because you have 4 different groups, right? So if you have a double bond with that carbon, that means it's just going to be sp2, so it's not going to be able to be a stereogenic center. So I'm going to cross them out. This is out. Oops. This is out. This is out. This is out. This is, oops. I don't know why I drew that. That's wrong. So this is out. This is out. This is out. This is out. Again, this is out. This is out. This is out. This is out. And then next trick. The next trick is you have to cross out any CH3s or CH2s. Why? Because you have multiple hydrogens, therefore you have the same group. So those can be crossed out as well. So out, 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 and out. So you only have one stereogenic center here. In this molecule, CH3 out, CH2 out, CH3 out. Okay, so CH2 out, and then you're going to have to analyze the situation. So, again, with this is going to be a stereogenic center because you have, you have different groups, okay? So, I would say that this is a stereogenic center because this whole group is one part, and then this whole group is another part. So, I would say in this part you have 2 rings, in this part you have 1 ring and a little bit. So that's how I would so this one is, and I'm gonna put it in a different color, so like, and then again, this does not have a plane of symmetry, so this one could also be 1. This could also be 1. And again, here, this could also be another group. And so you have 4 stereogenic centers in this example. Yeah. So now for the last one, again, you're going to have to cross out your CH2s and CH3s. And now you have to see what's left over. And so I only see that these 2 could have stereogenic centers because they're different groups. So, oh, wait. Oh, no. See how this one, technically, this group here is the same as this group. So, no, this is not a stereogenic center. So you only have 2. So in this you have 2. The last one. So you have 1. Then here you had 4. And again, you have to check that you're not having like a mirror or the same groups. And so like, for example, here you would have like a hydrogen, this group, and then 1 huge group, and then the other huge group, so that checks out. And then again here you have a hydrogen, and then this 1 group, this other group, and this whole other group, so that checks out. Then you do the same for these other 2 hydrogens, and you'll see that they are also going to check out. So yes, you have 4. And then lastly here, as you can see, this was the same, so you ended up having 2. Again, if you enjoyed this video or you want to see more videos on organic chemistry, and not just organic chemistry, like general chemistry or any other like pre-med, pre-health, pre-dental courses, I have all of them on YouTube on playlists. So each playlist is a course, and that's going to help you maximize your studying and be much more efficient for you guys. So I hope you enjoyed the video, and thanks again for watching.